Oops, I'm a bit late. I'll let us solve a contest now, okay? I don't know why am I doing. I'm getting views, that's the reason I'm doing this. But I would like subscribers too. This is simple. Just minimum three things, right? Or we could have written while n remainder 3 not equals to 0, answer plus plus. That was easy. So there is not much to explain there, guys. So now we are at B. Smallest to largest with one on top and n at bottom. Okay, 1 to n we have one from k of actions on the deck. Each action was one of those three. Remove the top card, remove the bottom card, either remove either the top or bottom card. Okay, so 0, 1, 2. So we have these things. We know at least these many bottom have been removed, at least these many top have been removed, and remaining things are like a variable, right? So top removed, bottom removed, in between you have some variable. That variable number will be from top, it could have been variable, or from here it could have been variable. But if you notice that, see the diagram, something in between must be removed. Okay, something in between must be removed. If you notice that. No, 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 no. 1 minute. Okay, okay, okay. So if you see the diagram, I'm just doing this because for the people that are watching. So some things in the top must be removed, some things in the bottom must be removed. But if the in between things, if they don't fill everything, even if there was one thing left, you could have made all of them as question marks. So in between thing is all of them are question marks or all of them are red. Okay. So if the total sum is n, then all of them are red. Okay? If k equals to n, only then all of them are red. So I'm just trying to see from here if f is within C2, it's a question mark, or if from here if it is within C2, it's a question mark. Otherwise, it's a positive, right? So f is less than or equals to this, or else it's a positive, or f is greater than or equals to, or f is greater than j minus C2. So everything seems fine except that I'm probably doing this wrong. Okay, I'm sleepy. I'm not talking much. I'm sorry for that. But I want to do quicker too. How can I do quicker? Maybe if I go for D, can I do it quicker instead of C? Combination of length is an array of n of n integers where each number 1 to n appears exactly once. An inversion, we know what's an inversion. For a combination, we define its inversion value as the number of its subsegments that contain at least one inversion. Formally, this is the number of pairs such that, okay, number of subsegments with at least one inversion whose inversion value is exactly k. Whose inversion value is exactly k. So okay, if k equals to nc2, it must be decreasing, right? Or else, one decreasing in between can split these two things into 1 minute. Involving these things, we may have n, and then from here, segments may have. Okay, not having any inversions. So if you see increase and then you see decrease and then you see increase and then you see decrease. So it's about increasing lengths. You have to limit these things. And if you have L length increasing, seeing the complement is better here. That gives you LC2 segments, right? Can we just do greedy? Whatever is the maximum length of LC2, take that. Can I just do greedy in increasing? Can we just do greedy in increasing? Try to increase, okay, as much as you can, and then reduce 1, because you can do greedy. Why can you do greedy? I think we can do greedy. Okay, sometimes it doesn't exist, it seems. So inversion value 1 doesn't exist, it seems. Means what? NC2 is 6 here. 6 minus 1 is 5. So we cannot have 5 length increasing ones, it seems. Why? Try to do greedy. 1, 2, 3. You can have 1, 2, and then it decreases. Okay, to increase and then it decrease, let's say. N is very small. Maybe we can brute force these weights. That's it. We can brute force these weights. So sum of some LC2s is, say, KB k equals to, let's say we solve the problem for NC2 minus k. Okay, this has been done. So now we want number of increasing subsegments. Okay, number of increasing subsegments. Each increasing subsegment, how will it look like? You have some increasing subset, and then you have next decrease, and then you have some other increasing subset. Subset is L1 plus L2 plus L3 up to so on less than or equals to n. All of these are possible, right? All these lengths are possible. Increase, decrease, increase, decrease, increase, decrease. All these lengths are possible. If you keep on decreasing, all of them are not being taken. Okay, equals to n. Okay, okay, because why? When it is decreasing, it is just 1, and then 1, 1, 1, 1, 1, and LCTs of 1 is 0. So with this being that, we want L1C2 plus L2C2 up to so on equals to k. Number of such things possible. If you can get these things for all these things, then we are done, and then we are good. And once we get these things for all these things, if you have L1 and L2, L3, if you can retrieve these things also, then we can just do this thing, and then we are good. We are done. This problem is not that difficult. It may be difficult for some people, but not for me. Bring me to your heart and tell you sorry for the mess. Okay, now we have to see for these sums what are all the sums that are achievable, right? Int dp of what are all the sums achievable? Uh, what are all the sums achievable in general? In general itself, what are all the sums achievable? Let's say we have for each sum we have what are all the sums achievable. Int s equals to nc2 of n. These are the number of total maximum sums, or this is the maximum sums, right? uh, lc1 plus lc2 up to so on, I think this is the maximum, taking all n. This is the maximum sum. So sum being 0, what are all achievable? dp of, so let's just keep, if that sum is achievable, we'll keep it as, uh, if that sum is achievable, we'll keep it as 0, otherwise we'll keep it as 1. Initially I will make everything 0. And along with that, what will I store is length of lost one. I will just store length of some length of something that we will store. If it exists, we will just store length of something that works in that DP. Okay, DP of 0 of 0 equals to 1. We are telling we are choosing 1. That's a bit not correct, but fine. So now we are thinking, with I being 1, what are all possible? We want to find these things, right? Just take last thing be L, means for int L equals to 1, L less than or equals to I, L plus plus. Okay, we can do these things down. We can do these things down itself. Right. So for all of these summations, we are trying to find what all are possible. Okay, dp of I of s equals to 0. So takes a total sum be 0, then that's possible. Okay. Now for all these things, you're using L. If dp of, okay, I minus L. So with this sum, if you can make, if you can make because you're taking this for sure, right? S minus if dp of I minus L of, with this sum, if you can form S minus NC2 of L, then dp of S equals to L. So now we have it for everything. Okay. So now we are having it for everything perfectly. If dp of k of, sorry, if dp of sum being n, k cannot be formed, C out 0 and L. Written. So the thing is, it's like some increase, some increase, some increase. This is a structure that you can make. So now I want to know what are all the lengths. Okay. L1 equals to dp of n of k, while n, okay, while n greater than 0, what do? We find one length that is possible with it. L equals to dp of n of k. Okay. Length dot push back of L, L minus equals to L, K minus equals to NC2 of L. Done. So now we have all the lengths. With these lengths, you have to form a permutation. Increase, decrease, or something like that, right? Increase, and then you will decrease once. How can I do that? Let's say you have everything increasing. Okay, I'll do one swap here, one swap here, one swap here, and then I'll make the last thing non-decreasing. Keep going. Just do one swap. Just do one swap. Just do one swap. Okay, take decreasing. No, it is simple. So I'm just going. We have increasing. L things swapping these two. L things swapping these two. L things swapping these two. And now we have swapped everything. Now it's all increasing. We just have to make from here. We have to make everything decreasing. Okay. From here. sort of p of I comma p of I plus n comma greater int of. I haven't done good programming here. I tried using more. I tried using more logic while I can. dp of s equals to l. Where is that? So one is possible, two is possible. One is possible, two is possible, three is possible. Here, six minus one, five is not possible, right? Okay. But then if you take one comma, hey, I'm taking too much time. Five comma 10. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It is 5, right? We have dp of n of. How is that happening? dp of n of. Okay. We'll do five. Why? Okay. Okay, why are we not outputting? Fuck, it's irritating me a lot. Why? Okay. Why is this not getting printed? What the fuck is happening? Why is this not getting printed? Okay, n has been reduced. That's the reason. Fuck. It's a shitty problem. I mean, it's an okay problem, but then I took too much time on that. My mind is not right, I think. If you make a as plus 1 and b as minus 1, what you want is you have to remove something and make the sum to be 0, right? You have to remove some segment and make the sum 0. So it is like minimum sum. You want the minimum sum uh, that's equals to that. Okay. You want the minimum length segment that is equals to the sum. If you take sum here, it is 3. You want the minimum length sum that is equals to 3, which is 3. You take the sum here, that is 0. So you need not do anything here. Here it's not possible because you have to remove everything. Even here it's impossible because you have to remove everything, otherwise you cannot get plus 3 anywhere else. Is there any other way to do it? Like I can see, like from here I have to see if there is some sum being equals to the next sum. Then if you remove that, remaining will be 0. So it's like the next sum should be that. So if you are here, if you have prefix sums and indices of this minus that sum, then you can get that, right? So you have minus 1 plus 1 need min length subarray whose sum equals to total sum. Okay. So you want ref of I minus ref of j equals to total sum. You want max such j. I'm not liking it. So what I will do is, for all sums I will maintain, all sums can be from minus n to plus n, right? Okay, my indices, the last index of this sum, minus 2, let's say. So initially you have zero sum. Okay, initially you have zero. Assumption is zero is at minus 1. Okay, we want latest j such that pref of I minus pref of j equals to total sum, which means, okay, Bring me to your heart and tell you sorry for the man. Hey, I don't mind. So whatever is falling short, it must be compensated by the number of people. So first question is, What is the answer for one viewer? Solve without any changes. So ACDR is fixed. Okay. So we have this AC, we have this DR. And for each people, okay, if the person is like this, whatever is gone, it will be compensated by P. So for each user, we have some minimum P greater than or equals to max of A minus AC comma 0 plus max of DI minus DR comma 0. Okay, this should be the P. Initially, all the P0 people will be there, and then sort them based on P. Okay, all P0 people will be there, and then we have some 2 or some people, and then you have some 5 people. The condition is number of the condition is, let's say it's failing at Z. Okay, it's failing at Z. So what does it mean? Number of people. So 2 appeared greater than 2 the first time, means less than 2 there are these many things. So the first thing for which less than the, like, whose number of things less than that or not, it will fail. Smallest Z for which number of people, number of P less than Z is less than Z will fail. So number of people less than this, if this number of people is less than 5, there it breaks. And then we only have these many people watching. So we should be able to find this value. What value? So if we can find for each Z, if number of people less than that, the value of number of people less than that, then we can do this problem, right? So for each Z, if you can find number of people less than that, and then you want smallest negative. So what happens? Some P will be gone and then a new P will come. Okay, that's what this is. This is just nothing but some P will be gone and a new P will come. And some P goes and new P comes, and still you should be able to find the smallest Z such that less than or equals to these things or these many. So frequency of something changes. Something comes forward. Something the P goes somewhere else. Still, we should be able to find the first smallest value that is occurring, for which less than things are smaller. So if this one goes, number of things less than all these values will change by minus one, right? So when frequency goes, something goes. Frequencies of all these things which are greater than that must be changed by 1. So all of them became minus 1. And still we should be able to find the smallest minus 1 you should be able to find. So if you can do range minus 1 means or suffix minus 1 and binary search to find the first minus 1, we can do the problem. We need segmentary. We cannot do binary search. And segmentary to find the first minus 1 we are done. Problem is not good. It's just segmentary to find first minus 1. You update frequencies and then you will again find the first minus 1. Or is there something nice here? I don't think there is anything nice. For each distinct value of p, you have their frequencies, okay? You have their frequencies, okay? You want all these people will not watch, and if those people are not watching, the higher people also will not watch. So you maintain this thing. When frequency changes, you have to update a range, right? So you have to update a range. If you are maintaining this thing, when frequency changes, you have to update a range. Okay, you have to update a range. You have to update a suffix or prefix, and you want the first minus one after doing that. So we must use segmentary to get the first minus one, right? How to get the segmentary for the first that gives me the first minus one? Yes, yes. Do you have that? We want the first negative value, okay? It's like some range additions and first negative value. So I'll just copy this one maybe. So we want, I mean, need not be this much. It can just be some lazy segmentary, I think. It need not be this much. It can just be some lazy segmentary. Does it has lazy? No. Okay, we have lazy, and I additionally want minimum minus one, right? Minimum minus one is what I want additionally. The first negative value is what I want. Wait, if I can just get range minimum, is that done? So if I can get range minimum, I can know first negative value. That's it, right? I can binary search to see the first negative value, right? Yeah, that would be enough. Okay, here we have minimum. And what is inf? Okay, we have segmentary. We have distinct values, right? And distinct values are within 1 to n, because distinct values are within 1 to n. Wait a minute. Is it n to 10? Some n to 10 thing is also possible, but then if segmentary works, let's use segmentary. Maybe some n to 10 is possible, but yeah, I don't know. Like if segmentary works, right, just find segmentary. So this is for all p we have frequency. So n plus 1 is impossible, right? Even n is impossible. Even n is impossible because you want less than people, sum to be n. Okay. I'm thinking, what if that guy doesn't exist? For this p, it became negative. But then if that guy doesn't exist, still it's worse for this guy also, right? that guy itself doesn't exist. So I think we can find the answer like this. So we maintain p minus this, right? We maintain p minus that, and then we want first minimum. I want first minimum. Initially make everything zero because we are trying to add things, right? We're trying to add things. Update does add. And then what do we add to this? For p comma p, we add p minus sum. Okay. What does this do? So let's say impossible be n plus 1. Okay. It's impossible to get n plus 1 people, right? Or let's just do this. If s dot range query of 0 comma n is greater than or equals to 0, return n. Okay. Now you have n being impossible. Till here there is a negative thing. This is binary search. V is negative, right? If you're trying to move forward, okay, if you can move there and still that is negative, then you do v minus equals to. So now you have this v. We want frequency of small because this is the answer. P minus s dot range. I'm not doing this thing well. I know I'm definitely not doing this well. This will give me frequency of small and then we are done. So now how to update? Because frequency of P has been added to all this range. We have to do range update. So frequency of P has been subtracted from all these things, right? So now I will add it to that range. Okay. Frequency of P has been added. Now I will update frequency of P. Okay. So what am I doing? I'm removing this guy first. I have removed that guy. And then I will update the frequency because this has been removed now. I'll again, after updating the frequency, I will again add that. Otherwise, instead of both of these, I can just do, I should do, I should add plus one, right? Because got reduced. I should add plus one. I should just add plus one here. Now new p equals to, this video is bad. Fuck. If P is this, I don't like contests at all. If answer equals to 4, 0 comes, 2 comes. Right. It should be frequency minus p. Or if I don't change this, I should just go for minus ones. I should just go and find greater than 0. 32440. Answer equals to first positive was here and its value is 1, 0, 1, 2. So it should be I should find the first negative and I should change these things, flip these things. Because what I'm getting is range minimum, right? So here 0, 1, and then we have it to be -1. And then we have frequency of 0 to be. This frequency was added to all of these things. Now we are trying to remove that one because that's gone now. And then this thing came. Okay, it seems correct now. I don't know when it became correct, but now it seems correct. It's not even a good problem. Maintaining something and outputting something. There is no logic at all in these educational rounds, I guess. I hope F is a good problem, but I cannot solve it in 30 minutes, right? There is a strip divided into cells numbered from 0 to m from left to right. You are collecting a chip that is initially in the cell 0. This seems a good problem. Can I solve it if it is a good problem? M is 10 power 12. You are controlling a chip that is initially in the cell 0. There is a trap in each cell. They are activated according to the following rules. At the end, 0 to m, the strip is divided into cells numbered from left to right. You are controlling a chip that is initially in the cell 0. There is a trap in each cell. They are activated according to the following rules. At the end of moves 1, 1 plus n up to so on 1 plus 2n, the traps in the cell. Traps are activated in cell X where X equals to A1 mod B. A1 B1 mod. Okay, what does it say? You have a number n, you have numbers ai, both are small, n is small, ai is small. At the end of first moves, these are all activated. At the end of moves 2, they are all activated. At the end of n moves, all of them are activated. In one turn, you either move or stay in the same place, then all the traps for this turn are activated. After you go there, it should be safe, okay? But they have told something for. Okay, okay. All the n reminder one things or consider or get will get. So fuck it now. So is login square not allowed? Why is it so shitty? Okay, it seems to be working. Then leave it. Otherwise, we can update the segment to choose two segments. See if this segment is good or bad, and then keep going. You can do that too. This is also not difficult problem, but I can solve it in 7 minutes, right? Shitty contest. M is big, okay? But with respect to n, tap has n different patterns. Pattern one, pattern two, pattern three, pattern four, up to n patterns. Tabs has n patterns, and they keep repeating. So n patterns keep repeating. Okay, n patterns keep repeating. We can only move left or we can stay in the same place. Okay. For each cell, what happens? For each cell, what happens? Trap, active, maybe trap, maybe active. That's what happens to each cell. Now, if you see that this pattern continues, it may be impossible, right? It may be impossible at times. But then, AI is also small, right? This seems to be a nice problem. I'm ending the stream.